So we are here today because we're talking about grafting. Grafting and budding are both ways that we can join different parts, at least two parts of plant material, and joining those together in a way that they're going to unite into one plant. So this is kind of one of those really interesting things that we can do with plants that there's really no great analogy for in people. Perhaps maybe something like an organ donation or something like that, but here we can take two different pieces, or three in some cases, and graft those together. In the bottom image here, you see a depiction of whip and tongue grafting, which we'll talk about later. And here on the right-hand side, you see the upper piece, which we'll call the scion, and the bottom piece, which we'll call the rootstock. And you can see this kind of light tan material that's formed in the middle. That's callus tissue, and that tissue is in part what holds these two pieces together and allows them to grow as one plant. So I've already started throwing in some terminology. We'll talk a little bit more about that here. So the scion is the upper portion of the plant material. We generally will consider that as the shoot system that we want. And we have the rootstock, which is the lower portion of the material. As the name implies, this is the root system that we want. Where we put those two pieces together and hopefully they begin to grow, callus together, and actually function, this is what we call the graft union. And if we have multiple grafts on a plant, we could have multiple graft unions. Occasionally, we may use something called an interstock. We might use something like this if we want a certain ornamental type plant. Sometimes you've seen those ornamental trees where they're on kind of a 4.5 foot or so stick, and then you have either the ornamental top or sometimes it's a weeping form, kind of lollipop looking trees. Those are often done as two or different pieces of grafting. So we might have the rootstock, we might have an interstock in between, and then we have our scion on top. So that would involve two different grafts to achieve that. Occasionally, because of some issues with how the scion and the rootstock material play together, or particularly if they don't play nicely, we might use an interstock to kind of run interference where the rootstock and the interstock get along, and then the interstock and the scion get along. And so that interstock kind of gives us a little intermediary buffer. Occasionally, we can also, and actually this is done quite often, reduce the scion material. Instead of kind of a long stick of multiple buds, we might use a single bud for that. And in that case, we just call it a bud or budding. And there are multiple variations to all of these. So here on the right-hand side, you can see someone beginning a graft here, and then here we have the attached scion to the rootstock. In this case, they're using a budding rubber, which is essentially just a rubber band that's been cut to tie and hold those two pieces together while that graft union forms. So here you can see a depiction. This is kind of through time, ultimately what this ends up being when we have our scion material. In the case of apple, for example, this might be the cultivar of the apple that we want to eat. So that might be Honeycrisp or whatever the case is. That's that upper part of the material. We have our graft union. We try to usually locate this fairly close to the ground, so the root system is actually then below ground. We'll have that graft union above, so that'll be a few inches above the soil when we plant that. And we have our rootstock, and sometimes we just call that stock, and we omit the root part. So we can have our scions and our stalks. If these grow together over time, we'll always have that graft union present, but that upper part, which would become the tree, that is from our original scion, and the entire root system is from our original rootstock. So why do we consider grafting, besides being interesting and being able to, say, change cultivars of an existing tree, or to do interesting ornamental things? Ultimately, we're trying to because we can do grafting, we're trying to achieve desirable features of both the scion and the rootstock. So there's something special about that cultivar of either the scion or the rootstock that we might want. This also allows us to insert a different cultivar on part of a tree. So we may, for example, have need some other pollination material out there to have successful fruit set. If we graft on what will become a branch or multiple branches, we can have that alternate pollen source, which would allow us to have proper fruit set. We can also do grafting as kind of an emergency technique where we can repair a damaged or a girdled tree. If we have something that's been damaged the whole way around, perhaps by a rodent in the winter, we can actually bridge over that wound with a kind of grafting. So lots of different reasons to do this. And here in this image, we have, this is the NC 140 high density cherry trial. And here they are training cherry trees in this upright spindle form. And instead of being kind of large, wide trees or small trees that we might think of cherries, here they're essentially grown on 6 to 8 foot high wires, in this case, acting more like a vineyard than what we might think of as a traditional orchard. But this allows good light penetration, good fruit set. We're able to get to all of the fruit and harvest it, as well as to apply any sprays or other things that might be necessary. And these would all be examples of grafted materials. So as I mentioned, we're looking for some sort of benefits. I think the scion part is probably the easier part to understand. So for example, with apples, I've mentioned Honeycrisp. If you were licensed to be able to grow that and you wanted to add that to your orchard, that's the scion material. So that's what you're wanting, whether it's for fruit or for flower or whatever the case is. I think the rootstock may be a little bit less intuitive, but it is certainly just as important. So we might use rootstocks for different purposes. We might use a very vigorous rootstock that might make trees more productive or efficient. We might also use a dwarfing rootstock to keep the size of the plant material down. That might aid in picking, that might aid in light penetration, and that might allow you to have a higher density system like we saw here with our cherries a moment ago. You might also use rootstocks for very particular resistance or tolerance capabilities. For example, we might have cold tolerance imparted by our rootstock or disease resistance. And ultimately, the rootstock is also providing anchorage and support, though usually when we're selecting a rootstock, it's for one of these other kind of supreme benefits. Phylloxera is a problem in grapes. This is mostly a North American disease, so some of the American grape varieties are resistant to this. Vitis vinifera, typically grown in Europe, this would be a lot of the European grape stock, which wines and whatnot would have been made from, are highly susceptible to this North American disease. So these North American rootstocks, Vitis riparia and Vitis avialis, are more resistant. So when phylloxera finally got to Europe, a lot of the American rootstocks were then grafted onto the bottom of the European vineyards in order to rescue those. So again, this is a prime example of that disease resistance being imparted by that rootstock. I mentioned dwarfing. Dwarfing rootstocks are for size control. Smaller trees result in more light penetration into the canopy, and that can lead to higher fruit quality since we're getting more light to the fruit. It can also be easier to pick as well and thin. So, if you have a smaller stature tree, maybe you don't need a ladder to pick it. Maybe you can use mechanical or other means. So different rootstocks have been raised entirely for the purpose of dwarfing, particularly in apples. These are some of the different cultivars: Malling 27, Malling 9, Malling 26. Those are those dwarfing varieties, usually below 40 or say 50%. We have semi-dwarfing ones, which go from about 50 to 60% of the normal size of whatever your scion would be. And then we have some that actually allow that kind of more full size or vigorous growth. Again, depending on what you were wanting, that's why you would choose your different rootstocks. So we can mix and match within reason. We just have to make sure that the rootstock and the scion get along, so to speak. So some of the factors that will affect grafting success, I mentioned this without the word, but they need to be compatible. They need to be able to grow together in a way that's not going to be antagonistic. Depending on what you're looking to graft, there may already be some research out there or guidance on this, which rootstocks or scions play well with others. If it's unknown, maybe you just try and you're the one kind of figuring that out. One of the key factors for grafting is that we need to have the cambial layers have a good match and good alignment. We'll talk more about that as we go on here. The timing is also important. So usually our scion needs to be dormant, not in an active period of growth. It may be set during the growing season, so it could be growing soon, but we're usually not grafting a living shoot onto our rootstock. We're grafting buds. Now, there are some exceptions to this. There has been tomato grafting and others where they're grafting with a leaf. I know that exists. That's not my area of expertise, so I won't say much more about that now. Here on the right-hand side, you can see an example of a whip and tongue graft. Again, we'll talk about that a little bit later, but you can see this kind of white line that is present here. That's the callus tissue. So that's kind of like the, like a scab, if you will, where these are starting to grow together. But importantly, what this callus tissue is doing is it's reconnecting the xylem and the phloem, or the water and the nutrients transport from the rootstock to the scion and back down. And ultimately that connection, that vascular connection, is what we need to have happen. And that comes from the growth of the cambium of both the scion and the rootstock. So this is why that cambial alignment is extremely important for this successful graft. Here you can see in the image to the left, this is a cut section of a branch. And what the blade is pointing to and the white arrow is pointing to is that cambium layer. So that's the layer that on one side would divide and turn into the xylem towards the inner part of the branch. That is for the water transport. On the other side of the cambial layer divisions, we would have dividing the phloem. And the phloem is for the sugar or nutrient transport through the plant. So this area of division is what will help those two pieces, the scion and the rootstock, grow together. The image here on the left, this is a cleft graft. We'll talk about cleft grafts a bit later, but what we've done is split that branch and inserted a scion material vertically down into it. Now you'll know these are much, much different in size to one another. You know, this branch is inches across, whereas this scion material is probably about as thick as a pencil, so maybe about a quarter or so of an inch thick. But ultimately what we're trying to do is line up the two cambiums, so the cambium of the rootstock and the cambium of the scion, and hopefully that will help us have that graft union form. Now, what you might already be thinking is that it's very important to have that contact, but that may not actually be a ton of contact area. And this is completely true. We'll have just the amount of cambium as long as our scion is, and hopefully connecting to that on the inside of the rootstock, and then again on the other side of this cambium scion piece, so on both sides of that. And that little amount of cambial contact, we're going to maximize whatever we can of it, but that little amount of cambial contact is ultimately what's forming that graft union. Here we have that same whip and tongue graft that we saw a moment ago, but what we are trying to do is to overcome the disconnection that results from cutting the scion and cutting the rootstock and putting the two of them together, where we don't have water flow from the rootstock to the scion. If we get proper callus formation, and that callus is the kind of first part of the wound recovery process, the callus cells are a bunch of undifferentiated cells, so they don't have any particular function at this point. Again, kind of somewhat like a scab when we hurt ourselves. But then these callus cells will either redifferentiate, or we will have connections extending from the scion and the rootstock, and this ultimately reestablishes that vascular connection. So we go from having essentially broken plumbing to having complete plumbing when our vascular tissue reconnects. Now, this may be evident from when you look at the scion. If you don't have things like bud break, if you don't have healthy looking material, you might infer that that connection hasn't happened. You might not see visible callus, and these are all signs that these kind of precursory steps that are required for that graft to be successful, we use the term take, hasn't happened yet. So you can kind of look at the material and kind of guess what might be going on inside. So again, that cambial alignment is extremely important. We need to make sure that we get as much of the cambium from the rootstock aligned with the cambium of the scion. So there's a whole bunch of different ways we can graft material. It kind of depends on the nature of the material that we're using, how big it is, where it's actually located, whether we can bring it all inside or whether usually the rootstock is located outside, perhaps in an orchard where we might have to go work in the field. So, but the general concepts of all of these different types is to get that cambial alignment and then to shape the scion in a way that will meet up with the rootstock and to cut the rootstock in a way that we can maximize that cambial contact. So whip and tongue graft, we can do this when the scions and the rootstock are fairly small and similar in size. We'll have some demos of that coming up here in a bit, but usually about the size of a pencil. When we do cleft grafting, this is for what we would call top working. These are when we have, say, rootstocks out in the field. So maybe this was a tree that was growing and we completely topped it off to change a cultivar, for example. You might do something like cleft grafting with this, where we can make some large wounds in the top of that rootstock and insert our scion materials. So usually the rootstock is much larger and it's located out in the field. So we have to do this entire work out in the field. Bridge graft, I've already mentioned, this is kind of a rescue type graft. So when we have an existing plant with a damaged or girdled trunk, this is where we may use a piece of scion to bridge that girdled area and hopefully try to rescue that plant. Kind of extreme grafting, if you will. So scion wood, we should use mature 1-year-old shoots. So these would be shoots grown from last season. You can select these from the material you're doing. Maybe you're doing some pruning and you can prune out some of these things. They're usually about 1 to 2 foot long, about as big as a pencil, and dormant. It may be that we take some of this growth during the growing season, early in the growing season, but usually we're trying to take this kind of during the dormant season. We want to make sure that our scion is free of winter injury. We may do some test cuts at the bottom of the scion wood. What we're looking for is the pith. I have that marked here in these 2 images. A light, either a white pith or a green pith is usually fine. Depending on the species, the normal pith could even be a light tan. What we're looking for is dark brown or black, something that would really indicate discoloration or desiccation or other kind of infection. So we usually want to avoid those. So we can make a sloping cut on the end of our scion material towards the base to check that as one way to look for that winter injury. When we collect our scion material, we're usually collecting a 1 or 2 foot long section, and this will include the tip with immature buds. This will also include the base with some other poorly developed buds. And somewhere in the middle of that scion, we should have a couple of good sections of bud. The way that this has been recommended to me is you take your 1 to 2 foot long section, kind of cut it into quarters, and keep the middle 2 parts. So you're going to ditch the top quarter and ditch the bottom quarter. And in that middle 2 sections is where you should have your good buds that you would want to do grafting with. If you're collecting these in the dormant season, you're going to need to store these to prevent moisture loss. Usually we'll wrap these in plastic. We may include some sphagnum moss, wet sawdust, or other things. That sphagnum moss would also need to be wet. We can wrap or bundle this up and put it in refrigeration. If you have access to a walk-in cooler or something like that, that would be ideal. The whole point is we want it at a refrigeration temperature, so about 40 degrees Fahrenheit above freezing, 4 Celsius for those of you keeping track in Celsius. And we want to slow the respiration. So the same way that you might keep certain vegetables in the fridge to keep them fresher longer, that's ultimately what we're trying to do here as well. We do want to make sure that we do not store this with any kind of fruit. Anything that's going to be ripening and giving off ethylene can cause these to spoil. So we do want to keep these materials separate if we're going to be grafting with these at a later time. We can do bench grafting. This is when we have small material, and this is when we might be able to do this inside at a bench, hence the name bench grafting. So if we have small rootstocks, this is an example of an apple rootstock we have in the class that I teach. These come in kind of a 2-foot long shipping container bundled in groups of 25. So this would be a couple of foot long with some nice roots developed. We'll have our scion material that was collected from an orchard. Usually these are the water sprouts that get pruned out of the tree during regular good thinning practices. And so we can take these inside and we can do bench grafting. So this is usually done in the dormant season. That graft would be calloused up for a period of time and then be planted. If it does have roots on it, those roots either need to get planted right away or would need to go in a similar setup to where we stored our scion material. So being bundled up in some plastic with wet sawdust or damp sawdust or damp sphagnum moss that would keep those roots from desiccating. If we have larger material, say out in the field, we can do what's called field working or sometimes top working. In this case, usually the rootstock is a large field grown plant. This is where we would come out and insert or graft on scion material. This is usually done during the dormant season, sometimes can be done during the growing season, depending on the type of graft you're trying to attempt. So in terms of grafting fruit trees, some dormant season work, we'd usually think about a whip and a tongue graft or a side or a splice graft. We can do a saddle or omega, and these just refer to the different shapes and the different kinds of orientations of the two to each other. The ones you see here in bold are the ones that we'll talk about in a little more detail as we get going. The types of grafts that we might do during the growing season are usually budding. So this is where that scion has been reduced to a single bud. We might do tea budding or June budding or chip budding. And we'll talk about all of those in a little more detail, or most of those in some more detail here. Here in the image on the right, you can see an example of a successful cleft graft. So we have our larger, probably 2 or 3 inch in diameter rootstock, where we've grafted on the scion material and that's begun to grow. You can see that kind of larger size rootstock here. Some general tools of the trade for grafting. You may use some sort of grafting wax or otherwise tree wound dressing, kind of a paint type material. It used to be that this tree paint was more commonly recommended for when you were doing pruning activities. We don't really recommend it for that anymore, but it is useful to have for grafting. You may have some regular masking tape. You might also want some polyethylene or kind of a plastic budding tape. This is a little bit stretchy and allows you to put some tension onto the graft as you tie it up. A sharp grafting knife, a good set of pruners, and they also make these hand grafters. These are some that my students use in lab. They have different blade configurations that you can remove and install that could allow you to do different kinds of grafts. This model in particular has 3 different blades. One will do a saddle graft where it's kind of a V shape where the scion, if we think about a horse and a rider, the scion would be the rider sitting on top of the rootstock, that's the horse. It has another blade that does an omega graft. It's kind of a similar setup to the saddle graft. And then it also has a blade that you can insert to cut chip buds, which we'll talk about here in a moment. And at this point in the presentation, we are going to switch over. So I'm going to unshare and mute myself, and Patrick will take over from here.
Okay.
And Grant, while Patrick's getting set up, if I can ask you a quick question, I usually save them all for the end, but I think that maybe we can address this now. When you were talking about saving the scions for later, and you're talking about refrigerating them, would vacuum sealing be a good idea or a bad idea for that?
I don't know that I've ever been asked that before. My intuition would be that vacuum sealing would probably not be what you want to do. We're not freezing them, and the tissue that's there still needs to respire, so it needs access to oxygen. I think if we vacuum sealed that up, we would probably end up with some dead scion material.
Yeah, I would agree with that.
Okay.
Okay, thanks, guys. Patrick, you can take it away.
Okay, so we've looked at some of the supplies here. So what we're going to try to do is show you by pictures and slides how to do the most common types of graft. And then we're also going to attempt a video to show it in action. And both have their pluses and minuses. So, but you'll kind of see it two different ways, by the pictures and by the actual video. But hopefully you'll get the concept out. You've already seen pictures a couple times of the whip and tongue graft. That's a real common one to do. We'll also be working on the chip bud. So to do the whip and tongue graft, you've got your scion and you got your rootstock, and you, if possible, you try to have them in similar diameter, and you make a nice, basically you cut them down to about 4 or 5 inches for the scion, and the rootstock you're going somewhere approximately maybe 6 to 8 inches above where the roots start. We do it the dormant season. So we've cut the scion down to, again, maybe 4 to 8 inches. It's got maybe 5, 6 buds on it. And so we take the scion and we've cut it with the pruners. And so we had a nice flat cut. Now we're taking the knife out and doing this long sloping cut. And the slide there says 1.5 to 2 inches long. That's probably a little longer than what we normally would do. If you could get over 1 inch, that would be good. So we do the long sloping cut first, just kind of an angled cut, and then we do what's called the back cut. And the back cut is the one we start about 1/3 of the way from the tip where we made the first cut, and we cut back into the wood, just straight down into the wood. And what we're trying to do is make identical cuts on the scion and the rootstock so we can interlock them. And so they kind of hold together on themselves, but we make it more secure by putting the plastic tie tape. Now, I've done some of these grafting workshops before. What do you see here is we've got the sharp edge of the knife here, and we got fingers here. So there is the potential for danger there. So you need to be really careful when you do this. And in the video, I'll mention it too, is don't force the knife down. Just take the wood and kind of push the wood up into the knife. That way you're a lot less likely to cut yourself. Now you can see we've advanced to the next picture here, and the knife has gone into the wood. It's going straight up into the wood. And we've gotten about 1/3 of the way through the initial cut. So we started 1/3 from the tip. We went like another 1/3 into the wood. Now this cut is done. We do identical cuts like we just saw on both the rootstock and the scion. So they both have the initial sloping cut, and then they both have the cut that goes up the middle. So they both have this second cut there. And if we do that right, then we can interlock them. We just kind of push one against the other, and they'll connect together there. In the case where Grant talked about the cambium, some cases where they're not perfectly matched, is you have to make sure at least one side, the cambium is in contact. And the other side, if it can be in contact, great, but if not, it doesn't matter. The worst thing you want to do would be to center the scion on the rootstock and not have cambium contact on either side. So we need that. Cambium is the key for a successful graft. In here we have one that was slightly mismatched, and so on the left-hand side, I think we got some good cambium contact, especially in the upper part of the scion. And then you can see on the right-hand side, there is no cambium contact, but this graft could be successful. So once we've interlocked them together, then we go ahead and tie them up with the plastic tie tape. This kind of helps press them together. Sometimes they're touching or they're just barely touching. By putting the plastic tie tape on, we're really getting them pushed together and more likely for the cambium to come in contact and for the callus to start forming. That callus bridge is important to kind of cement the two pieces together. So we tie the plastic tape, we wrap it around, and then we tie it off at the bottom there with a loop. And we'll see in the video too. This is, at this point, we would then come in with the either the grafting wax to kind of seal that whole area on where we've done the plastic tie tape, or we could use the pruning paint. We want to seal off any exposed wounds. The care of your bench graft, as the slide's talking about, is basically what we've got now. Is this picture doesn't really quite go along with it that well, but basically what we've got is we've done the whip and tongue graft. We've got the scion connected to the rootstock. The rootstock does have roots, so we can either pot it up or you can just lay it on its side. Another reason why we call it bench grafting is you can just lay it on a bench and just keep the roots moist to stop them from drying out. And then usually the callusing starts to form. The callus starts to form usually after about 7 to 10 days. And we're leaving this material, this plant material, at about room temperature. You don't want to go down in the 40s or 50s. You really want them, 65, 68, 70 degrees. That's where the callus is going to grow best. So then at that point, we can either, like, again, leave them on the bench or then pot them up. If you pot them up, you're eventually going to want to put them outside. We don't put them outside until they've started to form some new buds. And here we've got, this is actually, the picture here is actually of a chip bud, I think, and it's starting to grow, but let's go on here. So that's the whip and tongue graft. The other form of budding, or other form of grafting, is called budding. And budding is where we just take an individual bud. This can be done during the dormant season, but is generally done during the growing season, anytime from June through September. What we're doing is we're cutting out a bud from the new growth, from the current year's growth. In actuality, what nurseries do, like if you buy a fruit tree, it's probably been what we call chip budded. That's the standard practice for what nurseries do today. Is most of the grafted material you get was chip budded sometime in the summer. Budding's a very quick way and efficient use of scion material because you're only using one bud. There are two main types of budding: tea budding and chip budding. Tea budding, if we have time, we'll talk about a little bit. But with tea budding, you really need the bark of the rootstock to slip. So it's got to be well hydrated. And that's not always the case. So I'm not a big fan of tea budding myself, but I do like the chip budding because the chip budding does, you're making identical cuts on the rootstock and the bud. And so they fit together pretty good, and it has a pretty high success rate. So tea budding, chip budding, again, the chip budding is the one that I prefer because the bark does not have to slip. Supposedly the tea budding is a little easier to do, but yeah, but that's only if the bark's slipping. If the bark's slipping, it's kind of pointless. So for summer budding, you want to collect your budwood similar to what we would for the whip and tongue graft, only it's during the growing season. We want 1 to 2 foot long shoots, about pencil thickness. And again, we want like the buds in the middle 2/4 of that entire long shoot. Ideally, we just harvest the budwood shortly before we actually use it and cut out the buds. We can refrigerate it, but if you can use the very fresh material out in the field, all the better. Now with this one, again, we're going to do identical cuts on the rootstock and on the scion. And basically we're cutting into the wood at about a 45-degree angle. And we're cutting in about maybe about 40%, or a little over 1/3 of the way into the wood. So that's the first cut. Again, we're going to be doing identical cuts on rootstock and scion. What this first cut do, we'll make a little notch there. So we do the first cut, then we do a second cut behind it. So we've gone further up, whether it's the rootstock or the scion, we've gone further up, and we start at the top. We start up here, and we're going to cut down to where we had our first cut, which was down here. And so we slowly take the knife and push it down, trying not to cut through that first cut we had, because we just want to take that little section out, and then we're going to remove this piece of wood here. And so we've removed the piece of wood, and there is a little notch there at the bottom. And that's where we're going to, if this is the rootstock, this is where we're going to place the bud from the scion, is right here. So here we are cutting out the bud from the scion. So again, we've done the first cut below the bud and made the 45-degree angle, cut into it about 40% there. And then we're doing the second cut from the top and then pulling that out. And then we're going to get what we call our chip bud. So there we have it. We cut out the chip bud, and now we're going to place it onto the rootstock. So it's been placed on the rootstock. Again, we're tying it off with some plastic tie tape. And I guess what we're going to do now is, let's go back for just a moment, is we have a short, it's less than 10-minute video showing both the whip and tongue and the chip budding. So hopefully you'll find some humor in this video, but we're going to go, we'll just kind of go watch the video, and you're going to basically see in action the whip and tongue and the chip budding. At one time we thought about just doing it live here in the webcast right in front of you there, and it probably wouldn't show up real well. Even with the video, we had some issues of trying to get to see the key points that we wanted. But anyway, let's watch the video and see how it goes.
Today we're going to do the whip and tongue graft, and we're also going to try some chip budding. So the tools that we need, or the supplies we need, would include the 1-year-old budwood. This is wood that grew from last year's new growth. So it's 1-year-old budwood. That's what's going to graft best, whether we use a whole bud piece or if we use one individual bud that we'll use in the chip bud. So we need the budwood. We need the plastic tie tape. We're going to stretch this around the graft area to seal it, help seal it together so it won't fall apart, and also keep the moisture in. It's very important to label both your rootstock and your scion. Of course, we can write it down. We need preferably a sharp knife to do the actual grafting with, pruners to get the budwood to the correct size, and then we need some sort of sealant. You can use a grafting compound, like a wax, or in this case, I'm going to use tree paint.
Pruning paint.
Horticulturists say don't use anymore on any of the tree wounds, but for our grafting, it will suffice, although it is a little bit messy. And lastly, hopefully we don't need it, would be the Band-Aid in case something goes wrong. So I already cut these. This is going to be the cyan, the top part, which is similar to be like a Honey Crisp or a Red Delicious. And I cut it right below a bud. When I make my next cut with the knife, I'm going to actually cut that bud out. So we have a nice clean union area. I would take the rootstock first, and I would come in and make a long sloping cut, such as that. It's not quite deep enough, so I'm going to go again. And maybe one more time. Okay, perfect. Now the next thing I'm going to do is take my knife and go down, right down the edge here, about 1/3 of the way from the bark. Now this is the cut where you actually have the knife pointed towards your hand, so it can be a little dangerous. So what I like to do is just hold the knife steady and then kind of rock the wood against the knife so it just slowly cuts in. Okay, so now we've got that little notch. We're going to do the identical cut with our cyan. So again, I'm going to cut out this bud with my first long sloping cut. Once again, maybe not deep enough. Okay, now I think we've got it. So the same thing, I'm going to do the back cut. Again, the very dangerous one. Remember, hold the knife steady, just rock the wood into the knife. All right. So now we've got the two pieces, and we just join them together by pushing one against the other. Now, oftentimes, the two pieces may not be quite the same diameter. They're usually pretty close, so you try to get them pretty close. If that's the case, you want to make sure that at least on one side, the cambium of both are touching. Hopefully you've seen the picture of the cambium earlier. So we need to have those cambium areas in contact with each other. So I secured the plastic tie tape to right below the graft, or maybe an inch or so below. And now I'm going to slowly wrap it. And this plastic tape has a little bit of give to it. And so you can just kind of give a little extra tension. And what it does is it helps secure that graft union so it doesn't dislodge real easily. And then what I find is the tricky part is to tie it off. And we got it. So the graft union is right in this area here. So the next step, which can be a little messy, is we're going to come in and use the pruning paint. I'm not going to put any pruning paint on the bark itself, but yet on the plastic that I've already tied. And so that just kind of seals that area better, and hopefully it will callus and the two will come together. I also like to do a little dab right on the tip of the cyan so that it doesn't dry out. Like so. And this one is ready to go. If it had roots, we could actually pot it up at this point, or we could just lay it on the side for a few weeks and let it callus up. Now keep in mind, generally when we're doing chip budding, this is going to be in the summer, usually July, August, September. You can do dormant chip budding, but generally I like to do that during the warmer months of the year. And we're also using buds that formed that current year. So if we're doing this, say in August, it's buds that formed in spring, early summer. So to do it, you make identical cuts on both your cyan and your rootstock. So what I'm going to do is basically two cuts. I'm going to do a 45-degree cut about a ½ inch or so below the bud. Okay, and next I'm going to start now maybe about a 1/4 inch, 3/8 of an inch above the bud, and I'm going to cut slowly down to the first cut. And you need to go really slow, especially as you get past the bud, because the bark, the wood seems to have kind of slip, and you might cut out your first cut. So I'm going to try to go a little slower. Okay, I think we're just about there. Yep. So this is our chip bud. Notice it just has a little bit of wood there. And so we've got a lot of cambium exposed there. So now we're going to make an identical cut on the rootstock. We do a 45-degree cut below a bud. Although it doesn't necessarily have to be below a bud here, but. And then I cut the bud out, again, trying not to overcut in past the original first cut on the rootstock. Okay, so we got that off. So for this example, this is the from the rootstock, but it's very similar to the one we got from the scion. So we take the scion one that we cut previously, and we take it and we insert it. Okay, but there's a little notch there from our first cut, and so I'm able to put the bud right in there. It's held up there. I still need to tie it off, but we should have really good cambium contact there, and there's a very good chance this one will take. So then we come in, and I'm using this kind of a waxy stretch tape here, and this will kind of, just with your body heat, will kind of seal. Notice I've done that below the bud. And then once I get it to fully seal, I'll do one slightly above it. And you can see the bud there secured with this waxy stretch tape. And all things considered, that should probably take. If you want to be extra careful, sometimes you can take another piece and put it along the sides to make sure that's sealed as well. Some people will actually even just use rubber bands. But that would be your chip bud. So again, we're doing this more the July, August, September timeframe. So for the most part, I think we had a successful demonstration. Nobody got hurt. We didn't need to use the Band-Aid. So I think we're good to go.
Yeah, so that was the whip and tongue graft and the chip bud. So you've got to see it a couple different ways, through the pictures, through the video, maybe by seeing different ways and having kind of a reinforcement of the concept, maybe you've been able to get better of it. So as far as the summer budding goes, is basically, so we've done the chip bud, we allow the rootstock to continue to grow. And basically we let it go for that growing season, rest of the growing season. And then the following spring, assuming that it took, we cut off the top of anything above the bud that we inserted on the rootstock. So we're going to cut any of the scion above, or excuse me, any of the rootstock that's above the bud that we inserted the previous summer. And so that does pretty well. Just to kind of give you some odds here is with the whip and tongue graft, I usually get about 90% of them to take. I've taught some grafting classes, and people that have absolutely no experience and do the whip and tongue graft, they seem to get like about 50% of them take. So I think that's pretty good. For the chip budding, when I do that, I probably get about maybe 80% take on those. Again, as long as you get the cambium lined up, there's a good chance these things will take. There are the other forms of budding, or of grafting and budding. And depending on how much time we have left here, we'll look into them a little bit here. So besides the chip budding, you can do the tea budding, but the tea budding is the one where the bark's got to slip, because basically you're making a cut and another cut here. You're basically making like a little pocket for the bud to go into. So you're doing a bud similar to what you do with the chip bud, but instead of making an identical cut on the rootstock, you're just doing what's called a T cut. You do cutting a horizontal cut across and then one down, and you try inserting the bud through there. So with T budding, you do the first cut's a vertical cut, and then you're going to do the horizontal cut. And again, you got hopefully the bark slipping, and you can go ahead and make your chip bud or T bud here, and then basically very similar to what we did with the chip bud. And then we go ahead and place it into the pocket. Looks like, okay, there we go. That's what we wanted. So this is for the T bud. I'm not sure what happened with the other slide there, but for the T budding here, I know it's a little dark there, but the bud is just, they're just starting to slip the bud in there, inserting it in there where we've made, first we made the horizontal cut and then the vertical cut. Just like any of these other ones, we do seal it off with, in this case, plastic tie tape. And this was a picture we saw earlier. This was from either a T bud or a chip budding. And so the following growing season, we would cut this above where the chip bud or the T bud came out. Another type of grafting, Grant mentioned some, would be the cleft grafting. Cleft grafting is you can get ones of different size put together, so it is a good way to kind of change the top of a tree, say from Golden Delicious to maybe something like Honeycrisp. And usually when we do this, there's a special tool there that you see in the picture. It kind of separates the bark apart. It separates the wood apart. And usually when we do this, we'll do like 4 of them, 2 on one side and 2 on the other side. And the hope is, like you see in the picture on the right, the hope is to get at least 1 of those 4 to take. We really only need 1. Cleft grafting, you basically take the piece of wood and you taper it on both sides, so that when you insert it into the what would be our rootstock, you're trying to get on both sides, have a little bit of cambium contact on the much bigger rootstock. And here's a close-up of that where you can see the right one, we've got the cambium lined up in the blow-up picture, where in the other one, they're misaligned, and of course that will not take. Bridge grafting. So like the cleft grafting, if you do that, if you do 4 of them on a tree, usually you're going to get 1 of them to take. Bridge grafting is kind of like the last hope. When you have a situation where the tree has been totally girdled and you're trying to save it, you use the same 1-year-old budwood that you'd use for other types of dormant grafting, and we would do this during the dormant season, as we would with the cleft grafting. And you kind of clean up the area, and basically you're making these long sloping cuts on the budwood, and you try to match it up into the existing tree, try to bridge the area where all the bark has been lost. To be honest with you, this can work, but it seems to be very low percentage. Ideally, for every inch of diameter of tree, you want to use 1 piece of budwood, but it can be successful. I've had pretty low rates on this myself, maybe about 20%. where I've actually saved a tree. But it's sort of like a last chance that you can use, and otherwise the tree might die, or you just have the rootstock. So we both Grant and I would like to acknowledge that a lot of these the picture slides were originally put together by Dr. Paul D'Amoto. He's a retired fruit specialist with Iowa State University, and we appreciate him. He was kind of a pioneer in grafting for us here in Iowa, so we'd like to thank him for that.